Inverse variation. Inverse variation is the opposite of that, which says, the opposite which is, as one goes up, the other goes down. Okay, as one goes up, the other goes down. Maybe a way to think about it is, the longer you travel, the less amount of gas you have in your gas tank. As the distance you travel goes, your gas gauge goes down. That would be inverse variation. The longer you travel, the less gas you have in your gas tank. Its equation, now remember, direct variation, let's write it down here so we don't forget. Direct variation was y over x equals k, or y equals kx. That's direct variation. Today, we talk about inverse variation, which actually equals k equals yx, or x times y equals k. One times the other gives you your constant. We really gotta fix this. So put this in the notes. What other forms of this could I write out, those of you who are equation junkies? That way, what's their good business? I know. How else could I change this? What if I wanted to solve this for y? Y equals what, Sam? Alright, what are you going to do?
Yx equals k.
What?
Yx.
Yeah, okay, we can flip those two around. Let's go with something a little more substantial than that. Gabe?
Y equals k over x.
Yes. Y equals k over x. Or you could also have x equals k over y. Different forms. This is usually the one the book will give you, just like this is usually the one the book will give you too. But you can write it in any of those different ways. And examples of that would be, let's see if we can find a good one there. I don't actually like the one that the book have. I don't like the one that they have. I don't like any of the examples they give us here. Don't worry, I'm going to find one good here right here. Well, I guess we'll go with what book has. Okay, the rate you do something times the time you do something is going to equal 120. The rate times time, just like that, we had that little x times y equals k. That's kind of our thing. We know this here. If you make a table, watch what happens with this. Okay, let's say your rate, I don't know, what can we say we're doing here?
Eating cereal.
Let's say your rate times time, you're going 120 miles. Yeah, eating cereal.
An hour.
No, you're just going 120 miles. This is your distance. Rate times time equals this distance. Well, if you are driving at 20 miles an hour, your x is 20. How much time is it going to take you to go that 120 miles? 20 times what is 120? 6. It's going to take you 6 hours. Okay? But if you increase your speed to 30 miles an hour, then how much time is it going to take you? 4 hours. If you increase it to 60 miles an hour, it's going to take you 2 hours. If you go 120 miles an hour, it's going to take you 1 hour. If you go 1 mile an hour, it's going to take you
Oh, about 1 hour.
120.
Damn.
If you go 4 hours, or 4 miles an hour, it's going to take you 30 hours. Okay? This is inverse, indirect variation. And the interesting thing to know about this, well, if you look at the graph of this, check out what the graph of this looks like. Let's just say my x is, let's do this in, what do we have, 120? 20, 40, 60, 80, 120. 20, 40, 60, 80, 100, 120, and make this the hours. What do we go up to? 6, right? 1, 2, 3, 4, 5, 6. Oh, 120. There that is. If you were graphing this, take a look at what the graph of inverse variation looks like. At 6, at 20 I have 6, so here at 20 I have 6. At 30 I have 4, which here's 30, 4 is right about here. At 60 I have 2, which is right about here. At 120 I have about 1, which is right about here. At 4, which would be somewhere here, right? Is that right? Where's 4, what, 30? I guess I have to go way up there. Anyway, yeah, the graph of inverse variation looks like this, which is a function, but it is not a linear function. Whereas if you look at any graph of direct variation is always going to look like this. Direct variation will always be a line, a straight line that goes up like that, but it will be a straight line. Inverse variation, because of its nature there, it's going to be a curved line. And at some point, it's going to approach a line, but it will never hit that line. For example, here's a question for you. Mathematical people, answer me this question here. If you were going 1/2 of a mile per hour, how long would it take you to go 120 miles? 240. So here at 1/2, if I could put a point at 1/2, I'd have to go all the way up to 240. If I was going 1/4 of a mile an hour, how long would it take me?
480.
480. So here at a quarter, it would go way, way, way up there. Okay? With this inverse variation, there is no way. I will get awful close to this 0 point, but you will never, ever, ever get there. So at the top, it's going to look almost like a completely vertical straight line, but it's not. Okay? Because even you can't really go 0, because you can't say 0. You could never get to 0 because 0 times what number gives you 120? Nothing. You can't do it. So 0 is a limit that you can't get to. You can get awful close to it. I mean, if I said you were going 1/1000th of a mile an hour, how long would it take you to go 120 miles? 12,000 hours, which would be way, way, way up there. It'd be close to this axis, but it would never actually kind of get there for the most part. I don't know what to tell you about the rest of that. I want to find something that has. Let me get you a piece of paper.